When we look up at the night sky, we see the brilliant points of light that are stars. Between them there appears to be nothing, just a vast, dark, and endless emptiness. It's a profound and sometimes lonely thought. But this perception, this feeling of emptiness, is an illusion. The space between the stars is not empty at all. It is filled with a tenuous, almost invisible substance. Scientists call this the interstellar medium, or the SM. It is the very stuff of the cosmos, a hidden world that connects everything. It's a universe hiding in plain sight, waiting for us to unveil its secrets. So, what is this interstellar medium made of? It's a diffuse mixture of gas, primarily hydrogen and helium, the lightest and most abundant elements in the universe. But it's also laced with tiny grains of dust, particles of carbon and silicates, like cosmic smoke. This isn't the kind of dust you find under your bed. It is the raw material from which worlds are made. Woven throughout this mixture are invisible forces. Vast magnetic fields stretch across light years, guiding the flow of charged particles. And zipping through it all are high-energy particles called cosmic rays, travelers from distant, violent events. This seemingly empty space is, in fact, a dynamic and complex environment. Imagine drifting through a galaxy. You wouldn't be in a true vacuum. Instead, you'd be floating through incredibly thin clouds of this cosmic material. In some places, the gas is so cold and thin that there is only one atom per cubic centimeter. For comparison, the air we breathe has trillions upon trillions of atoms in that same space. Yet, when you consider the sheer scale of the galaxy, this incredibly sparse material adds up. The total mass of the interstellar medium in our own Milky Way is immense, equal to billions of stars. It is the reservoir of matter from which future generations of stars and planets will be built. This invisible ocean of gas and dust is not static, it is constantly in motion, a swirling, churning sea of matter and energy. It flows around stars, pushed and pulled by their gravity and their radiation. It gets heated by the fierce light of young, massive stars, causing it to glow with spectacular colors, creating the beautiful nebulae we see with our telescopes. These nebulae, like the famous Orion Nebula, are windows into the interstellar medium. They allow us to witness the intricate dance of matter and energy that fills the void. This is the true nature of the space between stars, not an emptiness, but a canvas of cosmic potential. One of the most astonishing truths about the interstellar medium is its role as the universe's cradle. It is the birthplace of all stars and, by extension, all planets. Within this vast expanse of diffuse gas and dust, there are regions where gravity begins to win its eternal battle against pressure. These regions are called molecular clouds. They are colder and far denser than the surrounding medium. Here, atoms of hydrogen have joined together to form molecules, creating the perfect conditions for new stars to ignite. These clouds are immense, stretching for hundreds of light years, and contain enough material to form millions of stars like our Sun. Inside these dark, cold molecular clouds, the process of creation begins. Pockets of gas and dust start to collapse under their own weight. As a clump of matter shrinks, its core becomes hotter and denser. It pulls in more and more material from the surrounding cloud, growing in mass. This process can take millions of years. The gravitational collapse accelerates, spinning the material into a flat, rotating disk. At the heart of this disk, a protostar begins to form. It is not yet a true star, as it isn't hot enough for nuclear fusion. It is a star in waiting, gathering the mass it needs to come alive. The birth of a star is a dramatic event when the core of the protostar reaches a temperature of about 15 million degrees Celsius. Something incredible happens. Nuclear fusion ignites. Hydrogen atoms begin to fuse together to form helium, releasing a tremendous amount of energy. A star is born. Its light and solar wind burst forth, pushing away the remaining gas and dust from its cocoon. This stellar wind carves out a cavity in the molecular cloud, revealing the newborn star to the universe. Often, stars are born in clusters, with hundreds or thousands of siblings emerging from the same cloud at roughly the same time. The disk of material that surrounds the young star is not wasted. This is the protoplanetary disk, and it is where planets form. The tiny grains of dust within the disk begin to stick together. They grow from microscopic particles to pebbles, then to boulders, and eventually to planetesimals, the building blocks of planets. Over millions of years, these planetesimals collide and merge, gradually forming the rocky planets like Earth and the gas giants like Jupiter. So, when you look at our Sun and the planets of our solar system, you are seeing the legacy of the interstellar medium. We are all, quite literally, made of stardust that once drifted through this cosmic sea. The interstellar medium is not a peaceful place. It is constantly being shaped and reshaped by powerful cosmic forces. Among the most violent of these are supernova explosions. When a massive star reaches the end of its life, it collapses and then explodes in a cataclysmic event. This explosion unleashes a blast wave of energy and matter that rips through space at incredible speeds. This supernova shock wave plows through the interstellar medium like a cosmic tsunami. It heats the gas to millions of degrees, sweeps up dust, and enriches the medium with heavy elements forged inside the star. Elements like iron, oxygen, and carbon. These shock waves are cosmic sculptors. As they expand outwards, they compress the gas and dust they encounter. This compression can trigger the collapse of molecular clouds, kickstarting a new wave of star formation. The beautiful filamentary structures we see in supernova remnants, like the Veil Nebula, are a direct result of this interaction. They are the glowing scars left behind, showing us where a star once died and where new stars might soon be born. The death of one star provides the raw material and the trigger for the birth of the next generation. It is a fundamental cycle of death and rebirth that drives the evolution of galaxies. It isn't just supernovae that stir the interstellar medium. Galactic winds also play a crucial role. These are massive outflows of gas powered by the combined energy of many supernova explosions and the fierce radiation from clusters of hot young stars, often located near the center of a galaxy. These winds can be powerful enough to push gas and dust right out of a galaxy's disk and into the space between galaxies, known as the intergalactic medium. This process regulates the rate of star formation. By removing the raw material, galactic winds can slow down or even stop a galaxy from forming new stars for a time. Radiation from stars also pushes and molds the ESIM. The intense ultraviolet light from massive O-type and B-type stars ionizes the surrounding hydrogen gas, causing it to glow brightly and forming what astronomers call an H2 region. The pressure from this light and the hot gas can create vast bubbles and shells in the interstellar medium, clearing out cavities that can be dozens of light years across. All of these forces, supernova shock waves, galactic winds, and stellar radiation, work together in a complex interplay. They continuously churn, compress, and redistribute the matter between the stars, directly influencing where, when, and how future stars and planets will form. Traveling silently through this vast interstellar expanse are cosmic rays. These are not rays of light, but high-energy particles, protons and atomic nuclei, moving at nearly the speed of light. They are messengers from some of the most extreme environments in the universe, such as supernova and the regions around black holes. As they journey across the galaxy for millions of years, they interact with the interstellar medium's gas and magnetic fields. Studying these cosmic rays and how they are affected by their journey gives us clues about the medium itself. They help us map the galaxy's magnetic fields and understand the violent events that created them. The story of the interstellar medium is a story of transformation. It is a tale of how the simplest atoms in the universe, forged in the Big Bang, are gathered together in the dark and cold of space. It's about how these atoms are then sculpted by the light and winds of stars and shattered by their explosive deaths. This enriched material then collapses once more to form new stars and new worlds. Our own planet, and indeed our own bodies, are a testament to this grand cosmic cycle. The calcium in our bones and the iron in our blood were created in the hearts of long-dead stars and traveled through the interstellar medium before becoming part of the cloud that formed our sun. So the next time you gaze into the night sky, don't just see the stars. Try to imagine what lies in the darkness between them. Picture the vast invisible clouds of hydrogen gently drifting through space. Visualize the tendrils of cosmic dust, the seeds of future planets swirling in the galactic currents. Imagine the faint glow of distant nebulae lit up by the birth of new suns. Think of the immense magnetic fields guiding particles on their cosmic journeys. The space between the stars is not an absence of things. It is the presence of everything that is yet to be. The interstellar medium is where the universe's past and future meet. It holds the remnants of stars that have lived and died, and it contains the promise of stars that are yet to be born. It is a place of quiet, slow-moving drama that unfolds over millions and billions of years. Though it is largely invisible to our eyes, it is the engine of galactic evolution, the stage upon which the entire cosmic story plays out. Understanding this hidden realm is crucial to understanding our own origins and the destiny of the universe itself. It is a reminder that even in the darkest voids, there is immense beauty and endless potential.